ready to talk about reducing fractions in this problem set. Before we do that, though, let's review some factoring ideas. You know how factoring is really important in this concept, so let's practice that some more. Remember, you learned two different ways to factor. If there's one term, you're going to factor into primes. If there's more than one term, you're going to use the distributive law to factor. Let me ask you a question. What's wrong with this? Well, what's wrong with just going like, I don't know, 3 times 2 times x plus negative 1 times 2 times 2 times 3? Isn't that factored? Didn't I write this? Didn't I factor the 6x and the 12, negative 12? The answer is no, that's not factored. You know why? You know why this is wrong and this is right? It's because this is still written in additive form. Remember the definition of factoring? You're writing it as a product. This is 3 times 2x plus negative 1 times 2 times 2 times 3. So don't make that mistake. It's really common. A lot of Math 90 students do that, and even Math 141 students, but you guys won't because you know what it means to factor, right? Anyway, so here we go. Before we get into the actual process of reducing, let's practice the other thing we're looking at, where you take a fraction and you write it as the product of two fractions where one of them equals 1. The trick is to factor completely, right? Factor the top and bottom into primes in this case. And then use all the common factors. The common factors, it looks like there's a 2 and a 3, right? So all the common factors break off and form a 1. That's 6 over 6. What's left on top would be 2 factors of 2, which is 4, and another factor of 3. So this is what you were doing last problem set. What we're going to do now is just one more step. We're going to say, since 6 over 6 equals 1, take it away, and the answer is going to be 4/3. That's how we're going to do it. This one, if you wanted to write this as the product of two fractions, you factor it, and it looks like the x's are the only common factor, right? So that's how you would do it. We haven't really even talked about what it means to reduce yet. The definition of to reduce a fraction means to make the denominator as small as possible. For example, 6/8 equals 3/4, but 3/4 is considered more reduced because the denominator is smaller. That's the definition. All right, so this is how we're going to do it. We're going to reduce these fractions here by removing a factor of 1. This is the process. Now, it's like everything, we learn the process, and then eventually we may start to abbreviate a little bit, which is fine, which is good, but learn all the steps first, like we were talking about. The first step when you want to reduce a fraction in this class is we're going to factor the top and bottom completely, in this case into primes, right? Then we're going to do that thing we did last time where we find the factors, the common factors that form a factor of 1. It looks like just the 3's, right? So break off the 3 over 3's, and then the other fraction is going to be 5 over 8. And then here's how we finish it. 3 over 3 equals 1, right? So then you just remove that factor of 1. 1 times 5/8 is just 5/8. So that's the answer. This is considered more reduced than this because the denominator 8 is smaller than 24. It may seem like a lot of work, but you'll see later that if you don't think of it this way, when we get to the more complicated algebraic fractions, you're not going to know what to do. So learn this process. Trust me, it will make things easier later. All right, so if you wanted to reduce this fraction, that means to make the denominator as small as possible. The first step is to factor into primes. You'll get good at that. And then take all the common factors to form your factor of 1. It turns out there's a 2, a 3, and an x that's common. You pull those out, I think you still have a 2 and a y left on the top, and I think you have a 3 and a w left on the bottom. Now here's how we finish it. This forms a 1, right? 6x over 6 equals 1. So you just take away that factor of 1. 1 times 2y over 3w, which is 2y over 3w. That's your factor. Answer. Let's take that negative 1, put it in the numerator. We factor into primes. We're right down to here now. Now you have to look for your factors of 1. Looks like a 3, and a 2, which is 18, right? 2 3's and a 2 is 18. So the factor of 1 is 18 over 18. What is the second fraction? If you take away a 2 3's and a 2, I think you have a 2 left on the bottom. I think you have a 3 and a negative 1 left on top. So then the way you finish this is you take away this factor of 1. This is just equal to 1, so you can remove that factor of 1. Final answer, negative 3/2. It's reduced because 2 is smaller than 36. Okay, for this one, we're going to factor the top and bottom. This is kind of sneaky. Watch this really closely. All right, so the common factors that's going to form a 1 are the 2 over 2, the two factors of 2, which is 4, right? Okay. What's the other fraction, though? What does the other fraction have to be? I think on the bottom you have to have a negative 5, but what do you have to have on the top? It has to be a 1, right? Because remember, when you multiply back through, you got to get 4. So it's 4 over 4 times 1 over negative 5. So now what you're going to do is remove this factor of 1. Your final answer is 1 over negative 5, which is the same as negative 1/5. So if you understand this method, that's why there has to be a 1 left on the top. If you don't understand what we're doing here, you might be tempted to say the answer is negative 5. And that's a pretty common error, actually. All right. All right, so I'll put it all together now. In these problems here, we're going to actually multiply and reduce. And the trick is you get 15 over 60, but the point is, why bother multiplying it out if you're just going to have to factor next step? Why not just factor right away? So if you want to multiply it out, you can, but it's a better idea to just start to factor everything right on the first step. Go from here right to here. Your common factors are going to be what? A 3, I think. Right? A 3 and a 5, I should say. There's a 5 and a 3. Okay, so here we go. Same question I was asking before. What's the other fraction going to be? If you take away a 3 and a 5 from the bottom, I think you have a 4. If you take away a 3 and a 5 from the top, what do you have left? A 1. So when you remove the factor of 1, your answer is 1/4. It's not 4. So that's why. Learn the process. Okay, a couple more, then I'll give you some to practice. Again, my advice is don't multiply it out. In fact, start to factor it on the first step. Look for your factors of 1. Let's see, I'm going to form there's a lot of them here. We're going to eventually abbreviate this step, but it looks like I have 3 factors of 2 in common, and I also have a 5 and a 3. Check me on that. There's 3 factors of 2, a 5, and a 3 that are common. So you pull all those off, you have a negative 1 on the top, and you don't have anything left on the bottom, but you have a 1 left. If everything became the 1, there's still a 1 left, because remember, you have to multiply back through to get the same thing you started with. This gets removed. This whole thing equals 1. When you remove the factor of 1, you have negative 1 over 1, which is just negative 1. So that's kind of elaborate. A couple more, then you can take over here. Instead of multiplying it out, let's factor everything. Look for the factors of 1. Again, there's going to be 2 3s, I think, a 5, a 2, and a W. So what's left on the top, I think, is just an X. You may have to hit the pause button and check this for yourself. And then I think you're going to have a 3 and a 2 left on the bottom. So this forms a 1. These are your common factors. So the final answer is 1 times x over 6, which is just x over 6. What's the trick on this one? This is negative 5 over 1, and then we don't multiply it out, start to factor everything. The factor of 1, I believe, is going to be a 5, a 3, and a 2. So on the top you have a negative 2 left, on the bottom you have a 3. When you remove the factor of 1, your answer is negative 2/3. There you go. Alrighty. Go ahead, hit the pause button. Try these. We'll go over them in just a second. Okay, let's go over these. So, multiply and reduce. The trick is don't multiply it out. Just start to factor on the first step, right? Look for your factors of 1s. I think I see, looks like a 3 and a 7, right? So that equals 21. So pull out a 3 and a 7. That's one of the fractions. The other one would have to be 4. There's a 2 and a 2 left on the top, so that's a 4, and here there's a 3, so the other fraction is 4/3. You can remove this factor of 1, and so the answer is 4/3. See? Next problem set, we're going to start to abbreviate this a little bit, but it's important that you pay attention now and that you learn all the steps. Okay? But we are going to start running a little shorter on the next problem set. Here, did you change it to improper fractions, and instead of multiplying it out, you started to factor it at this stage here. You get negative 1 times 5, 2 times 3 times 3, and the bottom is 3 times 5. It looks like we can pull out a 3 and a 5. That's a 15. Sometimes your teacher might write it as 15. Other times they might leave it as just 3 times 5. Anyway, what's the other fraction have to be? You're going to have a 2, a 3, and a negative 1, so a negative 6 on the top. But what has to be on the bottom? Remember, when you pull off a 3 times a 5, there still has to be a 1 here. Otherwise, you wouldn't multiply it to get what you started with. Remember, this is just the definition of multiplication in reverse, remember? You remove that factor of 1, your final answer would be negative 6 over 1, which is negative 6. Okay, here we go. This one, instead of multiplying it out, you factor it. Look for your common factors. Let's see, how about a 3? Looks like just a 3 and a 2, which is 6. So you take a 3 and a 2 out of the top and bottom, which is 6. The other fraction, you'd have to have a negative 10 on the top, 3 times 7, which is 21 on the bottom. You remove this factor of 1, final answer, negative 10 over 21. Now this last one is kind of hard. When you start to factor everything, notice when I factored things, is it okay to move the variables around and put them at the end like I did? Is that legal? The answer is yes. It's just the commutative law. In fact, I would encourage you to do that when you're factoring. Put the variables on the end. I think it just makes it easier to organize your work. Now this one is hard, and we're not going to be doing this quite as much writing in the next problem set, but let's do it one more time. It looks like you're going to have 3 2's on the top and 3 2's on the bottom in common, and also a 5, and they both have an x and a y. So this whole thing is a 1. Everything here is your factor of 1. A 5, 3 factors of 2, an x and a y. What's left from the top is 1 more factor of 2, and what's left from the bottom is a negative 1, a 3, and a w. Make sure you move the negative sign up to the top, so it's negative 2 of 3w. There you go. All right, we'll see you next time. Bye-bye.